recording. So counter vectorizer for converting text data into a matrix of token counts, and for multimodal naive Bayes, it is a naive Bayes classifier. And we have another package called pipeline, make pipeline, so which is used to create a pipeline that automates the workflow. Okay, remaining anyway, you know. And metrics is like it is a performance metric to evaluate your performance or to evaluate the performance of the model. We have a package called metrics. And coming to the next, so here I have taken text data. Okay, so this is what like it defines a small data set of text samples. I have taken small data set. The data set name is text, where I have certain text samples. Maybe you may call it as like corresponding labels called 1, 2, 3, like that. But it's a like samples, a collection of samples that represent positive sentiment. Like here, 1 represents the positive sentiment and 0 represents the negative sentiment. See the labels. So, okay. So here I have taken the labels, and uh, even you can write here another sample because I have another sample. So 5, like we have taken 5 samples, and those samples, 1 represents what? So 1 represents positive sentiment and 0 represent negative sentiment. So according to that, tell me. So this is a good book. I like this movie. These are the positive. That restaurant's awful. I don't like this place. These are negative. Okay. So 0 and 1 you are representing for the sentiment. Coming to the next. So I have given every for every command I have like every syntax I have written the comment so that you can understand. Okay. Now we are setting the test size. So in the earlier case, when the data is in terms of numeric, and it, like you know how to make the test and train. So see here, we made it here. So this is what test data and train data, certain splits you made it here. But that is the same thing when you are coming here. You are making here test size. Test size is min of 0.5 comma length of text minus 1. And this can be adjusted. So 0.5, 0.6. So adjust as needed, keeping it smaller than length of text. Okay. You need to see this one. As I have written this according to my data and I have already adjusted, you can do that. Ensure test size does not exceed the number of samples minus 1. Does not exceed the number of samples minus 1. Now, test size you made. Now, you're splitting the data in terms of train and test. Already test size you mentioned here, no? The same test size I'm passing here. Whatever the test size here I mentioned. So earlier, no, you have mentioned 0.2 or 0.3 like that. But here we are not giving 0.2 or 0.3. Already we made certain test size, and that the test size as it is you are giving here. With stratification, sets with stratification. That stratification you already defined here. Now you need to create a pipeline. That is what vectorization. I already told you what do you mean by vectorization. Okay, make pipeline counter vectorizer, comma multinomial NV. Vectorizer is equal to, or you may call greater than or equal to naive Bayes classifier. So you are applying your vectorizer. So you are taking counter vectorizer to make into the tokens, and after taking that, what you are doing? You are also calling a function, a model called multinomial NB. So once you have called your multinomial NB and you have created a pipeline, then what you are doing? You are making that as a model, and now your model is ready. And for this model, what you are doing? The same process. What we done? Your X and train, Y train data you are passing, and you are also taking Y prediction. Then you are calculating your accuracy, printing your accuracy values. Same thing. So once till you are making your X like till the creation or till the training of the model, a little steps are different in terms of text and numeric data. So once you already made into X train and Y train or X test or Y test divisions, once it is done, then automatically you have your X and Y train data or X and Y data that you are applying into the model by fitting it, and you are predicting and you are calculating your accuracy. These steps are little common, but the thing is the entire concept lies here itself. So we have calculated accuracy and classification report. You are also asking the metrics classification report. This is what precision, recall, F1 score. As I told you, classification model, you have certain parameters. One is accuracy, precision, recall, and F1 score. So these are the comments, no need to bother. So this is what the result you received. So how many of you are able to do this? Or do you asking me to share the code? Let me know quick. ఎవరమ్మా అది So do you want me to share the code or already you have executed? Let me know. So you said yes. So have you executed or you are asking me to share the code? Okay. So previous naive-based example, I hope you did it. I'm not sharing that code. But now next program is genetic programming. It is little bit, the code is little lengthier.
చెప్పరా కాల్ చేసిన
ఏమమ్మా ఏం చెప్తారు? Okay. So is this completed, ma? I hope I have shared the code. Have you executed? Yes or no? Only 12 minutes over. We have one more program to discuss. Can anyone please tell me, have you executed? Did you get the output? So I hope I'm audible. Then the next program, shall I start the next program? Call number 1. Yes. Okay. So implement an algorithm to demonstrate the significance of genetic algorithm. So what exactly genetic algorithm? So genetic algorithm is a optimization technique, right? Which is inspired by the principles of natural selection and genetics. And it is used to find approximate solutions to optimize and search problems. Where you have select in the algorithm when you are taking, where you have um, selection, crossover, mutation. So basically, a few key concepts here we have, which is population, chromosomes, genes, fitness function, selection, crossover, a mutation. Generally, population is a set of a set of candidate solutions to the problem, whereas chromosomes represents candidate solutions, typically which is like in terms of strings or arrays, which is encoded as a strings or arrays, and genes, which are the elements of chromosomes. Maybe you may call it as specific features or maybe parameters. And fitness function, which is very important here, which evaluates how close a given solution is to the optimum solution. Coming to the selection, this is the process of choosing the fitness individuals from the population for reproduction. Yeah, you need to select. Um, for example, when you are going for crossover and mutations or crossover and mutations, so you are taking two different breeds and which feature you want to take from one particular product or one particular plant, and you can take, you want to see tomatoes is an example. So tomatoes means it's a combination of potato and tomatoes. So new plant you have created here by taking some features of potato and some features of tomato. So this some features, what features you are identifying here, what features you are taking here, that that selection. So that is what the selection, the process of choosing the fittest individuals from the population for reproduction. And coming to crossover, crossover is nothing but recombination, combining two parent solutions to produce offspring with characteristics from both the parents. So you are combining two parent solutions to produce offspring with characteristics of characteristics from like both the parents. And mutation is also under genetic algorithm, which is randomly altering genes in a chromosome. In like when you are talking in terms of conceptually, you are selecting one particular position and you are replacing that position. If it is 1, you are replacing with 0. If it is 0, you are replacing with 1, like when you are solving the problem. So here you are altering genes in a chromosome and like to introduce variability and maintaining genetic diversity. So that is what actually a mutation definition that you are applying. So this is what a small theoretical part of your genetic algorithm. So straight away I'm moving towards your genetic algorithms. Okay, shall we start? So I'm like I need to have certain uh, import, like I'm importing a random function and like base create certain tools I want that I'm taking here. Import random. From deep import base creator tools algorithms. So these are the few packages I am importing here. So here we using deep library to define a simple genetic algorithm that maximizes the sum of a list of binary values. Okay. And now we need to define the problem. I just want to reduce the size. We'll see. Actually, I already coded, which is a little bigger program. This is what the program. But I want to reduce the size of it. Oh, okay. And let me see. Otherwise, we'll come here back. Okay. Define the problem. I want to define the problem here. And already we have taken creator. So for taking the support of creator, creator dot create. So I'm taking the support of create, like for what? For fitness max, base fitness and weights. So I'm defining the problem. Fitness max, base dot fitness, weights are 1.02. The rest of randomly it is going to take. And also defining the problem, which is individual. So fitness dot max, creator dot create, individual list, fitness. So what exactly these two statements? So what exactly happening here with these two statements? Still people are joining, admit all. So the first line is creator dot create fitness max base dot fitness weights 1.0. So here what exactly happening means you are creates a new fitness class. Here we are creating a new fitness class called what is that, fitness max. And what it is doing means it is inheriting from base dot fitness. New fitness class you are creating here, and this it inherits from base dot fitness, and the weights attribute is set to 1.0. Its weight attributes are setting to 1.0, and that is indicating that the algorithm will minimize the fitness function. You are minimizing the fitness function. And coming to the second line, creator.create individual list fitness is equal to creator.fitness max. What exactly happening here means, so you have an individual class called individual. You have an individual class called, so I have named it as individual, which inherits from Python's built-in list. So here, list is a Python's built-in list class. So that is going to be inherited from Python's built-in class called list. And each individual will have an associated fitness value of type created dot fitness max, which is already you have created in your first line. The first line itself, here itself you have taken fitness max. So you have created dot fitness max. So I hope now it is clear. Clear? Is it clear? Now I'm going to define an evaluation function called individual. So I just want to create a function called evaluation function. So I'm going to take eval function individual and return some individual. For that, here so here let me copy this and I'll explain this. Toolbox is it because almost the same lines we have, so no need to write type. So what I thought, I just copied it and let me explain you line by line. So here toolbox is nothing but a container. Toolbox is nothing but a container. Okay, toolbox is nothing but a container for functions and operations used in the genetic algorithm. This you need to remember. The toolbox is a container for, so I am initializing the toolbox. Toolbox is equal to base.toolbox. So what it will do means the toolbox is a container for functions and operations used in the genetic algorithm. It acts as a central registry where you define how individuals are created, evaluated, selected, mated, and muted. All these are the operations under genetic algorithm. Okay. So it acts as a central registry where you can define all these things, like how you define how, like where you define how individuals are created, selected, evaluated, mated, and muted, all things. Mutated, all things will be done in your toolbox. Okay. And here you have register. So everywhere see here register, register, registers, registers. And but in that you may have different functions, right? But like the second step, which is toolbox dot register at underscore bool random dot random 0 comma 1. So this registers a function of attribute boolean that generates random integers from 0 in between 0 and 1. In this case, what happens? It simulates a binary gene. So you are going to simulating the binary gene. The binary gene can be either 0 or 1. But what you are doing, your boolean values, your registers a function called attribute. What it will do, it will generate a random integers in between what? In between 0 and 1. The values will be generated in between 0 and 1. Whereas your binary gene is either 0 or 1, that these values, in this case, what happened? Simulates a binary gene to 0 or 1. Coming to the third one is individual. See, this is what? Individual, init, repeat. So what exactly this means? Here, this is individual creator, register individual creator. This register a function individual that creates an individual by repeating the above. The first one is there, no, attribute. So function 10 times. So the registers a function individual that creates an individual by repeating the attribute function 10 times. And each individual is thus a list of 10 binary values. Either it can be 0 or 1. Each individual is thus creates what? 10 times. 10 values is going to be created. But what? So again you said attribute. Attribute is a gene having 0 and 1. Attribute is having 0 and 1. Toolbox dot attribute. So how many instances you want to create here? 10. Then the third one called register population. Okay. This is what third one. So that is for register population creator. So this registers a function called population. The above one is individual. And the next one is attribute, right? So this registers a function called population that creates a list of individuals. Each individual in the population is created using the individual function. And we have evaluate, mate, mutate, select. All these are the operations of genetic algorithm. So we have evaluate function will be used to assess the fitness of each individual population. And we have mate. This is for generally a 2-point crossover function. Here we are applying crossover function. C x 2 point means crossover. C x means cross 2 point. This function takes two parents and produce two offspring by swapping segments of their genetic material or two crossover points. You need to have 2 points, and 2 points, by taking 2 points you are performing. Because I'm assuming that you're already aware of theory. I'm not concentrating on theory part, because you people have done a few problems on 1 point, 2 point, and n point crossovers. Assuming that I'm going a little faster.
No, yes, Shanti ma'am, they've done 1.2 points crossover.
Yes. So no
Yeah.
need to explain. So I don't want to go to theoretical explanation and problematic. So here we are applying 2-point crossover. Okay. And the next is register mutation operator, where a mutation function, like here a mute flip bit I have used, registers a mutation function like mute flip bit, which flips the value of each bit, or you may call it as gene in an individual, with a probability of 0.05. With a probability of 0.05. That is 5%. So each which flips the value of bit. You know what exactly mutation. So it will flips 0 to 1 to 1 to 0 with a probability of 0.05 or 5%. You may call 5%. Finally, you have select. This registers a tournament selection function called cell tournament. This is what tournament selection function, which is called here as cell tournament, which selects individuals based on a tournament size, which is 3. I have taken here the tournament size as 3. Each tournament, 3 individuals are chosen at random, and the best one is selected. I hope you are able to understand. So in every tournament or in each tournament, what happening? 3 individuals are chosen it randomly. Maybe multi individuals you may have, 10 or 100 or 1000 you may have. But in every tournament, what is happening? You are going to choose 3 individuals. And that too, that can be happened randomly. And out of which you are going to select the best one based on its fitness. Based on its fitness, you are going to choose 1 out of 3. So I hope you understood this. Whatever the code I just explained you now. Yes? Any doubts? Quick ma. Now I need to run the genetic algorithm.
Testing.
I hope more 7 to 8 minutes we have. By the time I'll try to complete this. And I need to run the genetic algorithm. So population toolbox.population, where my n value is 300. Generation, crossover, and mutation points. I have given generation, crossover points, and mutation points here. So where I am going to run the genetic algorithm. Now I'll explain you this. Let me copy this. algorithms and you are giving a sample to the algorithms like population, toolbox, crossover point, mutation point, and generation. And we have here verbose is equal to false. So if you did a few projects, you'll be able to understand this verbose. So here algorithms.ea sample, this function runs simple genetic algorithm. Population, like initial population of individuals. Toolbox, which contain all registered functions, which may be selection, mating, mutation, evaluation. And cross PB means crossing probability. Okay, cross PB is crossing probability. And mute PB is mutation probability, the probability of muting an individual. N-gen is the number of generations to run the algorithm. And verbose is, if set to true, it prints the progress of the algorithm. If set false, generally you will ignore the progress of, like you're not interested to display the progress of the algorithm, then you can go for verbose is equal to false. So the function iterates over the specified number of generations, applying applying selection, crossover, and mutation to evolve the population. I hope you understood this one. Now print the best individual. You are going to print the best individual among the all. Okay. So I have gone for a short code. Let me check. No module name deep. This deep, I think you need to install. If it is not accepted, then you have to install. So check. Simply what you have to do here to install. This is the code, right? More 4 minutes we have. I think it's sufficient. So pip install the it's still installing. So you people do the same thing. If it is showing error, then you can say successfully deep. Yes. So best individual is, so you got certain fitness values. So best individual and your fitness values also be the same. So I hope you understood. This is a small code. I just coded right now, and this is also a program where you are generating every time individual and best functions. So this is a little lengthier program. If you want, I'll try to share this
Shanti ma'am,
also.
shall we log in again
No,
after
madam.
this?
Actually, it's over.
No, if they have
Completed.
any doubts, they can.
Sure. If they have any doubts, they can. I don't have any objection.
Or we will have 1 half-an-hour session on Monday. Can
No,
we
I
have?
think we can wind up today if students want. So take the response from the students, ma'am. Ask the question to the students. Let them
Okay.
tell.
Yeah. Do you want to continue after this? Because I think it'll. We will log out in 2 minutes, anukunta kada ma'am.
Yeah, ma'am.
So you want ma'am to rejoin and explain this again? Will you guys respond? Naren, can you tell me? Do you wanted to log in again? So it's all clear, right? Okay. So can I get few more answers from others? Yeah, Shanti ma'am. They don't need.
Yeah,
So if they have any doubts, I'll ask them to. No, I'll ask them in the class.
sure, ma'am.
We can have Sunday or Monday, anta.
Still, they have any, like, do you have any doubts,
No,
ma'am?
no. What I meant is they will practice today and tomorrow.
Yes, sure.
And if they have any doubts, you can log in just on Monday for 15-20 minutes. Not more than that, if they have any doubts.
Okay.
Yeah.
So, so hardly more 20 seconds, not even 20, 15 seconds you have.
Oh.
I hope you have copied this code.